video, I wanted to walk you through the RTL diagram for the Lab 9. Okay, in Lab 9, you're supposed to be writing the sprinkler controller. All right, so the hint I gave you in the write-up was take a look at what we did in class for the traffic light controller, because you're going to do a similar approach where you're turning on stations in a sequential fashion, just like in the traffic light controller, you were turning on traffic lights in a sequential fashion. All right, so let's quickly look at this. We're going to have a couple of inputs coming in, a go and a reset. Later on, you'll have a wrapper where you can map that to the hardware components of the Basis 3 board. But the go and the reset, and then I wanted to tell you a little bit about the system clock. Our idea here is to slow down the system clock. So one thing you could think of is, let's say we had the sprinkler timed on a per second basis. The clock period could be 1 second per clock pulse. All right. The thing is, we don't want to really wait 1 second per clock pulse, so we're going to speed it up a little bit. So more of three clock cycles per second is what we're looking at for this slow clock that's coming in and driving our entire design. So we have to make this signal. All right. So down here, you have to instantiate another counter. You already have a counter in your design with a count value of N1. This would be instantiating this counter with a count value of N2. It would need a reset and a clear, but it's part of the Lab 9 module top. All right, so there we go. You know how to do that. You've done that before. All right, so I do want to talk to you about the parameters. Right, this other part of the circuit, you should have seen these before. Here's the bin to BCD, the display, the 7-segment decoder. All these things were part of the display. All right. So just like before, you have to separate out whether you're doing simulation or hardware. If you're going to do a simulation, the counter values need to be much smaller so that it won't take forever to simulate. All right. But if you're running it in real-time hardware, just like before in Lab 8, we had the N value for this counter was 19. But over here, to slow down the system clock to get it in the range of about 1/3 of a second per clock pulse, you need an N value of 25. So for every clock pulse, you divide the clock by 2 to the 25th. Okay? All right, so there's that. All right, the next thing that I want to talk to you about is in your system your sprinkler controller code, you're going to need to control the station and the timer values and the valves. All right, so the valves, all right, think of this as a sprinkler controller. So there's 5 different valves for 5 different stations. If you want station 1 to turn on, you turn on just the station 1 valve. You turn these on one at a time. Okay, once station 1 runs, you turn that valve off. Okay, so if you go back and look on the video, you'll see the LEDs are representing the stations. Okay, so as the sprinkler controller goes between different watering stations, only one of those valves or one of those LED lights is on at a time. Okay, the next thing is your sprinkler controller has to communicate with the display logic. All right, so in your sprinkler controller design, you'll have a station number. All right, it goes through 0 to 5 stations, so that takes 3 bits to represent 5 numbers, or 0 to 5. All right, so you'd have this output that you want to display on the display. Okay, so notice this wire gets connected here. Remember, this is 3 bits, so we're doing a concatenation thing where we're adding the 0, station wire to make this a 4-bit input. And if you recall from Lab 8, X3, okay, X3 without going through the BCD, this is going straight through. That's just going to show the station number on the leftmost 7-segment display. All right. The next thing is on the display, I want a blank on the second 7-segment display. So this is what I talked about in the lab write-up. You can modify this 7-segment decoder to have one of the unused code values, right? 0 through 9 is used, but this is code value 11. We can make code value 11 turn on none of the display, so it would blank. all right, when you have this tied to X2. So X2 is always going to be blank, so that's why we put this code in here. We had to modify this code, the 7-segment decoder, to make that happen. All right. So the next thing I want to have happen is on the rightmost two 7-segment displays, I want the 10s and the 1s place represented by the bin to BCD. So we're putting in the station time that's left. All right. So why do I have this concatenated thing? Well, in Lab 8, you used an 11-bit binary to BCD module to convert a binary number to a decimal display. All right, so in our case, for this lab, the maximum station time is 99. So you wouldn't need the hundreds place, you just need the 10s and the 1s. Okay, so you see the 10s place goes to the X1 display, and the 1s place goes to the X0 display, and that would let us display the proper station time on the output display. Okay, so I think that covers some of the basic stuff that you need to know. Hopefully you'll have some fun with putting together Lab 9.